Welcome to Jonathan online class. In this video, we have practical physics analysis on the board, precisely electricity, and we are concentrating on meter bridge experiment. Then, many people are wondering how to set up a meter bridge experiment apparatus and the principle of operation in the experiment. But before we talk about this, there is need for us to understand the working principle of the Wheatstone bridge. The Wheatstone bridge is like a pre-model to meter bridge. The Wheatstone bridge is made up of the four resistors, like in the setup here, R1, R2, R3, R4, such that when you now close the circuit and the galvanometer, which is a sensitive instrument that detects very small amount of current, is deflection. The deflection is at 0 point. That is the balance point. Your current that flows here is equal to current that flows here. Current in this arm equals to current in this arm. In that case, you will now get that R1 over R2 is equal to R3 over R4. With this understanding, we now go into the meter bridge, which is the center of the experiment. For those of you preparing for SSCE exam or those preparing students, this is a typical guide. Now, look at this diagram on the board. The meter bridge has two arms with a 1 meter rule with tiny wire on it. That 1 meter is 100 centimeter. The two arms, the left hand arm here is where you put the unknown resistance. That the resistor with unknown resistance. The right arm is where you put the resistor with known resistance values, like the resistance bus as provided. Now, this is the setup. Now I have my arrow here, that is unknown resistance. I call it R1. I have my R resistance bus here labeled Rx, my resistance bus. Now I have the voltmeter connected in parallel to the variable resistance bus there with different values of resistors, so that it can now determine what happens as I change the values of the resistors, what happens with the corresponding voltage supply or terminal PD in the circuit. Then here, from here to here is 100 centimeter, that's the 1 meter rule. Then I have the galvanometer here, a sensitive instrument, which must be there in that experiment to work out because it gives us the balance point. So even if it is not required in the instructions provided for the exams, it is a must that you have to provide the galvanometer to make your setup workable. Now, here you have the point here. There's a point here. There's a gap here which is closed by these resistors. They have the point here, connection to the galvanometer. Then the galvanometer is connected to the jockey. The jockey is a metallic conductor. We use it to tap on the wires, on that meter rule. So to get the point, the meter rule is calibrated, of course, 0 to 100 to know the balance point at each interval or procedure. Now, we have here the battery. Remember, the battery, when you have one dry cell, it is 1.5 volts, 2 is 3.0 volts, which is stable for this experiment if you don't have a DC supply accumulator. Then you have the key here, which is the switch. You have the ammeter for measuring the value of the current flowing in the circuit at each interval. Then we have the rheostat. The rheostat here is for varying the current value in the experiment, especially when you are not provided with certain values of current to be determined. You can use the rheostat to vary the values of the current reasonably as you proceed in the experiment and the recorded as well. Now, if here is L1, then from here to here, let me call here maybe C. Let me call here balance point P. Let me call here P, that balance point P. So if AP is L1, then P to B will be 100 minus L1. So that is my L2. My L2 is 100 minus L1. That is it. Since here is 100 centimeter. Then you proceed in the experiment. Remember, the procedure is that you set up this and close the key. Then you check your terminals. If the ammeter is flowing backward, you change the terminal. It has to be flowing forward. The same thing with the voltmeter. Then you might be asked to record the initial value of your current and the voltage, that as you vary the current with the rheostat and the corresponding voltage, then you will be asked to, you now have to tap, before you do that, you tap this jockey on this until you get a zero deflection. That is, the galvanometer is like this. You have left and right reading with 0 point. When it is zero at 0 point, something like the clock hand is at the 0 point, then you know that is the balance point. Then you record your L1. So in that case, you proceed with the different resistance given to you. You might be given, for example, here I use 2, 4, 6, 8, 10. It can be 1, 2, 3, 4, 5. Each in the resistance bus. When you require 2 or 1, you unplug that particular resistor plug. You are using it. If you need more, you unplug. You are using it. That is how it works. Then the next question I know why some people will be wondering is what will be the trend? What will be the observable happenings in the experiment? So in each case, remember, this must be, you must close the circuit and tap this at a balance point. You have to remove the resistance required. Then you tap, close the key well, tap this left and right until you get the balance point when at zero deflection. Then you record your L1, you record your current, you vary the current by sliding the rheostat. You vary the current, you record your current in ampere, then you voltmeter, you record, then you record your balance point here. So as you are changing resistor, these things will be changing, the current will be changing as you are varying it with this, the voltage will be changing as you are changing the resistance in the resistance bus, and the length will be changing, because remember that R is proportional to L, which means R1 is proportional to L1, and R2 is proportional to what? L2. So ordinarily R is equal to KL. This is the constant of proportionality, which is depending on the nature of the wire. From here, it is observed that as we are increasing the resistance here, the current will be decreasing value. Then the voltage will be increasing value. This is because as the length is increasing, the resistance increases, the voltage will be what? Increasing as well. So it is somehow proportional to the length as well. So this is what happened in the system. So the L1 will be decreasing. L1 will be decreasing value. Why L1 should be decreasing is because R1 is constant in that experiment. We want to determine the value of that unknown resistance. And as we are increasing this one, the length will be increasing because R increases with length. So as the L2 will be increasing. So as L2 is increasing value. As L2 is increasing in value, then it is shifting this side. Therefore, L1 will be decreasing because R2, which is our resistance bus values, are increasing, making L2 increase in line with this proportionality, while R1, which is constant, will be diminishing in that order. So then I put an evaluation. You might be asked to evaluate L2 over L1, which I label D. So when you evaluate it, your value will be increasing as well. It should increase in value because these quantities that produce them, the L2 is greater than L1. So this will be increasing, and this is increasing. So this will be increasing as well. So then the reason I expected this evaluation is because from the relation R1 over R2 is equal to L1 over L2, which in my case here, if you plot a graph of, if I have R2 is equal to, if I make R2 subject formula, it will be equal to R1 L2 over L1 mathematically. So plotting graph to determine the slope. If I plot graph of R2 against L2 over L1, my slope will be R1, which is corresponding value of or approximate value to my unknown resistance in my circuit here. So that is why I speculate this. So the graph could be to plot a graph of Rx, which is my R2, my Rx, that the values of the resistor, against D, which is my L2 over L1. So, and the slope will be the gradient of Rx to what? Delta D, that delta Rx over delta D. So this is what you keep in mind. You can verify this also in your lab with this setup experiment. Thank you for paying attention to this class. For more of these solutions or analysis in physics and mathematics, Do not forget to contact me here. Then if you have not subscribed to my YouTube channel, click the subscription button, share, comment, like, and drop your questions. God bless you.